So it's 1 o'clock. Once again, I would like to welcome you to the coffee lecture from the Chemistry, Biology, and Pharmacy Information Center. My name is Jožica Dolenc. I'm a chemistry information consultant here in the Infocentrum. And today I would like to show you how you can very easily access a Cambridge structural database through WebCSD. So Cambridge Structural Database, as you may know, is the world's biggest repository for small molecule, organic and metalorganic crystal structures. So basically structures which are resolved by X-ray or neutron diffraction techniques. If you're interested in inorganic structures, then we have a different database, ECSD, which I have presented some time ago. I'm going to say a word on that later. Cambridge Structural Database has been established in the 60s already, and at the moment stores over 1.2 million structures. You can see the annual growth of the database on the left-hand picture. And on the right-hand picture, you can see all kinds of molecules that you can find in the database. Now, the whole database with all its sophisticated tools is at ETH Zurich installed at the Small Molecular Crystallography Center. And I'm not going to show you that today. What I'm going to show you today is the online interface to the WebCSD, through which you can really easily search for structures in different ways, and also download then the structures and also do a little bit of analysis on the structures. But if you would really want to do more specific analysis, then please contact Michael Wörler from the Small Molecular Crystallography Center, and he can give you access to the server where the whole database with its specific tools is installed. Yeah, maybe you've heard about Mercury already, because Mercury, for example, which is one part of the tools from Cambridge Crystallography Data Center, is also available for free of charge. For visualization and analysis of crystal packing. But the Mercury installed locally here with us, it has much more functionalities. It's much more powerful. Yeah, so there's always this difference between what you can get for free and what not. All right, from here on, I will do now a live demo of the database. So to access the database, you have to go to this address or search simply via Infocentrum WebCSD, and then you'll get the link. And then this is now already the first possibility. You can do a very simple search by searching compound names, DOIs, if you found a structure in the literature, for example, or if you would like to see all the structures that have been deposited by a certain author, you can search that, and so on and so forth. So let me give you an example. Here, when I search for a compound 6-amino-6-oxohexanoate, I've prepared these searches already to make it a bit faster. So it's a name search. And then you can see here, you can add new search fields, different ones. So for example, if I want structures of this compound that have been recrystallized in methanol, I can say that. Yeah, so then this limits a little bit my search. And what you can then see here is that I can either search only Cambridge Structural Database or only inorganic crystal structure database if I would want that. Or I search both of them. So I'm going to now search for both. Now, ICSD is the database I mentioned before for inorganic crystal structure. And if you're interested in that, just look at our YouTube channel. We have a video recording of my coffee lecture on ICSD, because we license both actually at ETH. We license access to WebCSD and ICSD as well. All right, so I'm not going to go into details here. I'm going to now do a search for this compound, which is clearly organic. So it's going to be present only in CSD. And I'm going to do a search. And here you then see, in this case, I have really only one result. It's only one structure with that name. You see some basic information about space group and cell, unit cell, and then here is the molecule. You can have different representations. You can add labels if you like. And then down here, you can say, yeah, I would like to see the whole unit cell. So you can do that. You can see the unit cell. This is sometimes really, really useful to know. And then, yeah, if you want more, you can see bigger packings, yeah. But that, I think, doesn't bring us much now. So I'm going to go back to no packing. This is my molecule. And if I would now like, if I would have a more complex molecule, this one is really simple. But if it would be more complex and I would like to measure some distances, this is now also possible here with those icons that you have below. Yeah, so it measures distances and so on. And then come the details, the position number, data citation, formulas, crystal details, experimental details, and here it's also the recrystallization solvent. I specified methanol, that's why we got there. For this molecule, we also have a link to PubChem. Not for every molecule that exists, but if there is one, then we have a link. And then we come to the left-hand side, and here you can download the zip file. So you can, if you would like to have the coordinates, basically you click here and you say you want the zip files with any available structure or factor data and reports included. You need to put in your details and then you get the file. So that's how easy that is. And this is a simple, this was now a simple search. I have to say this simple search works really well if you have simple molecules with simple names, or if you have identifiers from some journals or so on. Else can get a little bit tricky, but there's structure search. I mean, chemistry like structures, and they have now an updated version of the Sketcher, as you can see. And here you can do a lot of things. You can do substructure or similarity search. And you can draw as you're used to. You have the periodic system, all the bonds and so on, and some templates. Now, for today, since I don't have so much time, I've prepared a template already. If you have a molecule drawn with ChemDraw and you save them in a mol file, you can then easily upload that. So here is something, a peptidic fragment, I would say. So I have it here now. Let me now click somewhere else. Oops, no, wrong. I'm sorry. Click the wrong button. So let me do again. Upload template. Once again. Open. Let me do it again. Open. Yes. And then you need to click on some button to stop uploading even more of them. Yeah, so here's now my fragment, which I want to search in the database based on structure. Now, there's more you can do. You can, for example, if you search this fragment, you can adapt it here, that's clear, but you can also add 3D parameters, for example. If you would like to measure the distance between those two atoms in the structures that are in the database, you can mark them and go here. So click on this add 3D distance. And then you can even say, I want to constrain it. So I'm only interested in structures where this distance is between certain minimum and maximum. That's possible. So that would happen if I turn this on. Now I will not do that now. I will just say I want that the search also monitors the distances. Yeah. So I say OK here. And similar you can do for all kinds of things. Also, you can define angles between planes, I think. Let me now maybe do a torsion as well. So this is a long molecule and this is rotating. So if I would like to see distribution of torsional angles here in this side chain, I can also say, yes, please monitor this torsion. And again, I could constrain it if I want, yeah? And then you would get only a limited selection of molecules that would fulfill the constraints. So let me stop with that. So now we'll do the search in the database. It will be a substructure search. I could also do a similarity search. And we'll see how many molecules have been deposited that have this peptidic fragment inside. And we got now to 16 results. Maybe I make this slightly bigger, like that. And what you can see now, since this is already a little bit more complicated, actually only this brown part on the right-hand side or the green part on the left-hand side is the fragment that I draw, and everything else has been added because of the substructure search. Yeah, this is basically what happened here. An exact search is no longer available in WebCSD. That has been available with the old sketcher, but now no longer. And then again, you can explore this. What is important, if you now go, for example, to this structure, before we had only the download button to download the zip file. Now we have also download parameter data. So, and this is a CSV file. And if I download that, then what I get is just a simple text file with the information on the distance and torsions I was interested in for each of the structures that are now in the result set. And you may ask yourself why there are several numbers for each result. That's just because they are really given. Yeah, they are in the files. So, and you can then further analyze that with other tools. So this is, I think, some very nice option that they have now implemented in WebCSD to also do analysis on the database structures in a very easy way. Many more of these kinds of analysis you can then do with a local installation, of course. Okay, now I'm gonna quickly show you the other two searches. So there's a possibility to do a unit cell search too. So if you have a crystal and you have measured certain dimensions of your unit cell, you can put the numbers in and check if this has already been done before, if somebody has found something similar, for example. And if I do that, I get now a couple of entries which have exactly the same unit cell dimensions. So this is possible. I'm not going to go in details here. And then we also had the possibility to do a formula search. For example, I made an example here. If you would like to search for crystals which have more than 4 platinum atoms, more than 4 chloride atoms, and 2 to 4 germanium atoms, and you allow also other elements, yeah, you can also search in this way. So, and since I allowed other elements, I actually got one result, which is a very nice molecule that you can see here. Yes, so with that, I need to stop. These are the 4 basic types of searching WebCSD. There's a coffee lecture card up front there. And for those who are online, I can maybe put the coffee lecture card into the chat. I can't see. I think I need to stop sharing to see that. Chat. Yep. Okay, that should work. Yeah, that's a coffee lecture card for those who are online. And with that, yeah, I'm finished for today. I'm happy to answer any questions regarding that. But before that, I would like to thank you for your attention. Thanks for coming here. Thanks for joining us online. And tomorrow, Leo, my colleague, will give also a very interesting coffee lecture. Also for the students, I think, in this moment about chemistry learning apps. So I very much welcome the students and also other people to join tomorrow. Thank you.